Welcome to another BigQuery demo. Here we're going to be looking at partition tables, specifically a column that is a date partition table, and what that means for querying less data when you're writing your queries against a partition table. Well, first and foremost, we need a query and a data set. I just happen to have one as part of our data insights e-commerce data, which is transactional data for web analytics. And we're going to go ahead and copy this query from the demo that's in our public repository. All this code is public that you're seeing here. And I'm going to paste it into BigQuery. And again, I like to preview the data set that we're going to be querying before we actually run the query so I can see what we're dealing with. So this table is data set, data insights, e-commerce, all sessions. Let's see how big it is in the details. It's going to be 5.6 gigabytes, 21 million rows, and the data itself is transactional information about somebody visiting an e-commerce webpage. It's actually the Google Merchandise Store, and this is just sample raw data from there. But that's not really that important. What is important for us is if you look at the details and you scroll down, you don't see any information about the table being partitioned. There's no partition column. What partitioning, again, is inside of BigQuery in a table. This isn't like an analytical partition. This is an actual partition on the column itself. You're going to see when we run this query. Let's go ahead and run it now. It's actually cached because I ran this a little bit earlier. So I'm going to, of course, when you're doing performance demos, you want to turn off cache in the query settings. I was like, wow, that executed fast. You can see that it processed 205 megabytes only to return 0 results. You might say, hey, there's something broken with the code. Why is it returning 0 results and processing all that data? Well, the best answer is to go look at what the query itself is actually doing. It's counting the number of transaction IDs and the date of the transaction from this e-commerce table where it has a transaction ID. It's not null. And here's the really, really, really important part, that the date itself is on or after the year 2018. Well, that's interesting. Why do you think there's no results for this where clause filter? If we go back into our data and you preview the data, this will give you a little bit of a hint. And you scroll over and you start looking at some of the date values that are just stored as integers here. We have to parse them out. You see 2016, October 4th, 2017, 2016, 2017, 2016. In actuality, there is only data from 2016 and 2017. So this is a year snapshot in the past. So it has nothing on 2018. But normally, without partitions on your database columns, the database has no idea to know that without opening up that column and looking at all those different field values and doing that comparison. And it's a pretty small amount of data, 205 megabytes for that particular query to actually go in and process that. But wouldn't it be better? I mean, you can imagine extrapolate this. Instead of having 25 gigabytes, you have 25 terabytes of data. Wouldn't it be better to execute that query faster and automatically know whether or not your data has data for 2018 or not? And that's what we can do with a date partitioned column. So the next part is we're actually going to be creating a date partition table with just a couple lines of SQL here. SQL Data Definition Language, DDL, is how you can create tables using the code. I'm going to paste that second query in. Now, before we actually run this create operation, I'm going to run the bottom operation, which basically says, count all the transactions in the formatted date. It's essentially exactly what we saw before, except it has no where clause filter. And it processed the same amount of data, 205 megabytes, and you can see this is the exact result. So it has 365 rows, which will tell you it is a year's worth of e-commerce transactions. We're just taking the total amount of people buying from the website and aggregating it by the individual day. So 365 individual days. It looks like the data is from 2016 to 2017, sometimes time spanning that era. Now, normally what you would do is you would save the query results as a table, say results right here, and you want to save it, so you can save it to a BigQuery table, but we're actually going to be doing that inside of DDL, the data definition language. I always prefer creating tables not with the UI, but inside of SQL. So if you save this in version control or in like a README file here, people will know how that table was created and not just by some UI magic. So how do you store these results in a table instead of just showing the results? Well, simply you can just use create or replace table. Now, what's new to a lot of folks who haven't seen partitions before is you can basically say, hey, when you're storing this table, I want you out there on disk somewhere in the BigQuery ether to actually partition it by a particular column. Now, it has to be of, as of the time of this recording, one of 3 special data types. Either a date, like a partition by day, a timestamp, or newly supported is an integer range. This helps you actually optimize the storage out there on disk. I'll show you what I mean. So let's go ahead and run this. And this will create a new table for us called ecommerce.partitions. And as soon as that gets created, we're going to see what that table actually looks like by going to the table. And immediately tells you, hey, this is a partition table. What does it actually mean? Well, I'm going to go into the details, and you'll scroll down. You see we have a little bit more information here than we did previously on the full table. It is a partition table. It's partitioned by day. So day level information. So each day is stored in its individual partition. We'll get at what that means with our rerunning our same query before. And this is the field that it is, date formatted. And by the way, we're not requiring users to filter based on a given partition. But if you have a really, really, really large table, you may require them to actually have a where clause filter. So now we're going to rerun the previous query. But this time we're running it on our newly partitioned data set. So interestingly enough, you can immediately see this query is going to process 0 bytes or nothing when it's actually run. So instead of that 205 megabytes, it knows already before you actually execute this that, hey, I know all of my partitions. It's like that metadata that the BigQuery native storage has access to, and none of them have a value after 2017. So 2018, it's just find nothing. So immediately it says, I didn't have to even open up any of that data. I just know that there are no partitions that have 2018 data. As opposed to, say, if you had 2017, of course, the data set would have some very, very small amount, right? And then boom, returns the results to you from that table. All right, that's how you can quickly create a date partitioned table. And again, it supports down to the individual day. And the larger your table is, and the more your users are querying and filtering based on those date parameters, like say last 10 days or last 30 days, the more you don't want them to have to go through every single row when you can use a partition to speed up your data. In a subsequent demo, we'll take a look how you can expand on partitions with an additional performance option called clustering on specific columns as well. But that's it for partitions.